I've been flying FPV, first person view style flying for several years now and really enjoying it, but more specifically putting FPV systems into fixed wing aircraft rather than flying FPV drones. Why is that? Because I like that real immersion you get from flying the RC aircraft as if you're in the cockpit. Now, what makes it even more realistic lately is if you use head tracking to capture head movement while you're flying and a gimbal inside the cockpit of the aircraft with the camera, FPV camera in it, so that it pans, tilts and even rolls as you move your head while you're flying it. It really does make it so immersive. Now, I've done this with several aircraft. I've done it with several jets, scale and non-scale. I've done it with gliders and I've done it with warbirds. And I'm always on the lookout for different aircraft that I could do this with. I think I would really enjoy that level of immersion, that level of realism. And I know there are others out there, and there's a growing community of people who enjoy doing this as well as line of sight flying. What's made it challenging up until now is that you have to buy the model from one manufacturer, you have to buy the FPV system from another, and you have to buy your head tracking and gimbal system from a third company typically, and that makes it quite a technical project to put together. Now, I did always think there was going to be a point at which one of the aircraft manufacturers would see that there's a growing community, a growing enthusiasm for putting FPV systems into these RC aircraft, and FMS are the first ones to do that. They have partnered with XF Robot, and I've used quite a lot of XF Robot products, their head tracker and their gimbals, but they've partnered with FMS to come up with an economical system for you to integrate into FMS aeroplanes. So this is SyncPilot from FMS in partnership with XF Robot, the guys who are the specialists in this head tracking and gimbal department. They have several products. But if I open the box for the head tracking element that you'll need, then you'll see you get the instructions, which I've read, they're very good. And there are three things in here. The first is the head tracker. So this is what captures your head movement and is going to be attached to your FPV goggles. Then you've got the head tracking transmitter. So this has its own aerial, and the job of this is solely to transmit those head track movements from the head tracker itself. So you see there's a UART port in the top here, and there are pins, 4 pins in the top of the transmitter. So, and double-sided tape. I'll do this later, but you would peel off the backing from that tape and then push into those pins into the UART port. And then with the 3N dual lock, you again attach that onto the head tracker and put that on your FPV goggles. Something like that. Then, when this is turned on, and as you move your head left and right, it will send that as a panning signal from the transmitter to the receiver that's in the aircraft, and the same for up and down head movement. It will send that as tilt to the receiver in the aircraft. And those signals sent from the head tracking transmitter would be picked up by this receiver. which has 4 ports for pan, tilt and roll. So actually it's not just left and right, up and down, but also if you move your head like that, then also it would capture that. But the gimbal that you can get from FMS is a 2-axis gimbal, not 3-axis. So this would be solely for pan and tilt. So in here you get 2 servos that you would plug into this head track receiver, and there's also the frame as well, in which you would put those 2 servos and your FPV camera. Now, without any FPV system, there's the FPV camera that you put in the aircraft, but also the video transmitter. With some systems it's called an air unit, but let's call it a video transmitter, a VTX. And there are different systems on the market, principally DJI and walk snail cadex. And they all those VTXs are different sizes, and that is why FMS, together with XF Robot, have come out with 3 different frames to hold those VTXs. So first we've got a VTX mount and cooling fan for DJI O3. The second one is a VTX mount and cooling fan for DJI O4 Pro. And the third one, VTX mount and cooling fan for walk snail cadex Avata. So you've got 3 different options there. Now, why has it got a cooling fan? Because any FPV pilot out there, and I've certainly found this, will know that some of these FPV systems get very hot, particularly when they're running at full power after you've armed them, and they really do need a bit of airflow over them to keep them cool, not too much. So that is really good that FMS have included a little cooling fan that you can use to keep the VTX cool. Obviously when you're flying, then it should get a little bit of airflow over it if you allow for that. Particularly if you've got an open cockpit, then that's not going to be a problem. But if you're on the ground static waiting to fly, it could be a problem. And if you've got an enclosed cockpit, that could be a problem. So when you've got an enclosed cockpit, it's important to have a hole at the front and at the back of the cockpit so that you do get a bit of airflow moving through the cockpit, especially when it's flying. Now, that's great that you've got the complete system there, but you need an aircraft to install it in. And I've done this for a few aircraft, and FMS have gone that step further, and they've now also provided a modified canopy for that 80mm BAE Hawk in Red Arrow scheme, and this is it. So you've still got the canopy, transparent canopy with the frame, but you've also got it modified in here so that you can easily drop in that VTX mount and the gimbal. About as plug and play as you're going to get it. So what I'm going to do now is put this together and show it working in that 18mm BAE Hawk Red Arrows. Okay, so first step of assembly, I'm going to put together the 2-axis gimbal. So you'll see in the packet you've got 2 servos with their arms, and then there are 3 pieces to the gimbal and a little bag of screws, black and silver, and the instructions. You might not spot it, but just to point out, the servos are actually different. One is for 180 degrees, that is for pitch, and the other is for 280 degrees, and that is for yaw. Basically because you want more angle, more rotation for your yaw axis, so that you're effectively turning your head to look over your shoulder to see if anybody is pursuing you. That really does help. For 100, we don't need so much angle for pitch, because we're really only going to be looking up and maybe slightly down over the side of the canopy, but certainly not down, because we can't see through the bottom of the fuselage. So take that 280 degrees servo and put it into the base of the gimbal, like I've shown here, and use 2 black screws to hold it in place. So that servo is for yaw, or panning as I would call it. So the next step is to take the yaw arm, or the panning arm, and press this on top of the servo in this orientation. Hold that yaw arm in place with one of the smallest silver screws in the packet, and also press the servo arm into the side of this piece. You may have to use a pair of pliers to push that in place firmly to make sure it is flush with the fitting as I've got it here. Take the second servo and press this into the other side of the servo arm and retain it in place again with one of the smallest silver screws that you'll find in the packet. This is the pitch or tilt servo. The FPV camera mount piece of the gimbal slides on top of the pitch servo in this orientation, and then is held in place by inserting one of the longer silver screws to hold it in place like a clamp. So let's take that assembled gimbal and put it into the modified canopy for the 80mm BAE Hawk Red Arrows. So you'll find that the transparent plastic comes off very easily. It's just temporarily attached in the factory with 2 glue points. We'll have to more solidly attach that later, but for now just take that off. You'll notice in the packet that you've got 2 ply plates, some screws and some stickers. Take this ply plate and attach the gimbal to it using 4 of the longer silver screws. If you look underneath, this is what it should look like. This is my DJI-03 FPV camera and VTX, and you can see here that I have put the FPV camera into the FPV mount on the gimbal and just held it in place with 2 DJI screws. Take 4 of the black screws and use those to hold the ply plate in the front of the canopy. Next is to assemble the VTX mount with its cooling fan. Important to have the correct version, so I've got the DJI-03 version here. That's because the VTXs that you get from DJI and Cadex Walksnail vary in size and their dimensions. So yes, let's carry on with 03. So on the table, these are the individual parts. You've got the fan at the top. The 2 lower right pieces is the frame to hold the VTX, and then the bottom left part is to hold the aerial. This is the second ply plate that we're going to use to mount the VTX into. So take one of the frame pieces and screw it onto the ply plate using 2 of the longer silver screws. Then push the VTX into the frame and attach the other side of the frame and screw that in from the bottom as well. Now there should be a gap under the VTX. That's quite important because it will assist in cooling. Just make sure you get the VTX the right way around. Then we put the VTX aerial into this piece. Do that first and then use 2 silver screws again to hold that in place from underneath the ply plate. If you look underneath the ply plate, it should now look like this. The cooling fan has 4 mounting holes, and these slide onto the 4 prongs that you have pointing up from the VTX mount. Now there are no screws to hold this fan in place. What I would do is use a contact adhesive like Yoo-Hoo Pour. I certainly wouldn't use super glue because then it would be very difficult to remove if we needed to pull the VTX out for some reason. So just use a glue that will reasonably hold it in place.
There shouldn't be too much force on this fan anyway. It should just rest in place. But I don't think a friction fit is good enough, so just use a contact adhesive. So that VTX ply plate is going to fit into the back of the canopy here, and we just hold it in place with 4 of the black screws. You'll notice that there are holes in the back of the foam here at the back of the canopy, so you can route the VTX cables and the cooling fan cable out through this into the bottom of the fuselage. And you've also got the same at the back of the front compartment for the 2 servos for yaw and pitch, so route those into the bottom of the fuselage through that hole as well. This is what your canopy should now look like, quite a clean install. And if you put the plastic canopy over the top, it looks like this. Obviously, you're going to have to secure this transparent part in place. You could use a contact adhesive or tape. But for me, I think I would probably use tape. I'm going to have an SD card in my VTX that I might want to get to, or get to the USB port on the side of the VTX. So I think tape might work better. And this is the SyncPilot receiver. This is what gets the signal from the head tracker for pitch and yaw movements. So the lower servo in the gimbal is for yaw. So that plugs into the leftmost port labeled Y. And then you've got the top servo for pitch. That plugs into the port marked P. There is a port for roll, but this is a 2-axis gimbal, so we're not using that. But since we're not using that, the fan plug can go into this port so that it gets the necessary power it needs to operate. And then you've got a separate lead that comes with this receiver that plugs into the V port, and that is what we use to power this receiver.
Okay, so now I've assembled that gimbal. Let's do a quick demo. So I've got the head tracker here with its transmitter on top, connected into the head tracker UART port and held together with a bit of double-sided tape that's included. And I've got some 3M dual lock that I'm going to use to attach this to the top of my FPV goggles so it captures head movement as I'm flying. Then I've got the SyncPilot receiver for the head tracker here with the 2 servos that are in the gimbal and the included lead to provide power to that receiver. Now and you'll typically do this as well, you'll have that plugged into a spare port on your receiver, and the power for the receiver will be provided by your speed controller. If you don't think that's going to be providing 5 volts, then you need to look at providing 5 volts in a different way to the SyncPilot receiver. But I'm going to use, just for the demo, a 4.8 volt nickel metal hydride after I've turned on this head tracker. So to see the battery status on this head tracker, you click the M button once. To turn it on, you click and then hold it, and that turns it on. Then power the gimbal via the receiver. And you notice straight away it's looking over here. So what I need to do is to set it to a neutral position, and this is what you will need to do after you've powered up your model, powered up this receiver, powered up the gimbal effectively. You will want to make sure that when you take off you're looking in a neutral position. So you need to take your model out to the flight line, set it down on the ground, and then stand and have your head in the position you are going to be comfortable with flying in that neutral position, just looking straight forwards. And then you hold down the M button on the head tracker, and it will go to that neutral position. Store that as the neutral position. So if I put it down here and do the same thing, then it has gone back to that neutral position. So left and right, up and down. Now, something I've always found, and I've got a lot of experience flying fixed wing FPV, is that when you move this 45 degrees, currently this moves at 45 degrees in yaw, but when you're flying FPV, it's better if it moves at least a 2-to-1 ratio. So if I move my head 45 degrees, then this yaws 90 degrees. Because if I want to look quickly over my shoulder, then I don't want to have to physically turn my head through past 90 degrees really. So a 2-to-1 ratio works really well. So they include this CW head tracker piece of software that you can plug into the head tracker USB-C port. Just happens to be in the other side, so I'll plug that in. Select the COM port that it comes up with and then do start debug. Now use the plus and minuses, don't type in the numbers. I think there's a bug in this software where it doesn't recognise it if you put in the numbers manually. So use these plus and minus and get to the number that you want and then do save flash. And then it will commit those values into the head tracker so that it sends, in my case, the double values. So when I move 45 degrees, this moves 90 degrees. That's a very useful feature. This also allows you to change the center position and save the parameters that are on this head tracker should you want to do that, and upgrade the firmware should FMS or XF robot come up with a newer version of the firmware that goes on this head tracker. Also, the head tracker can be used with XF Robot's own C20 gimbals. If you were to do that, you would need to change this value to C20 rather than the PWM gimbal value that is there. And the C20T gimbals are, well, they're a lot more expensive and they come pre-assembled, really, not with separate servos, but it's one unit. So have a look at those. I'll post the link to those in the video description and the pinned comment. But that aside, this gimbal works very, very well. And if you want to get into head-tracked FPV, then this is definitely something you should look at, particularly in combination with the canopy design that FMS have come up with to plug this in very, very quickly, like I've just shown. Now, if you're considering flying FPV for the first time, making that leap, I would also urge you to think about going a little bit further and looking at flight controllers like this Speedy Bee. This is very good for a number of reasons. If you're flying FPV, it's great to have telemetry provided in the FPV goggles, altitude and speed, the return to home arrow, the vector back home should you get lost, because everything looks a lot different when you're flying at 200 feet, and the distance from home and things like that. It's very useful for that. And also for autonomous flight modes. And I tell you why that's really important, because it is always possible you could lose FPV signal and therefore everything in your goggles goes dark. I've only had it happen once or twice in all the time I've been flying FPV. But should that happen, it's very nice to have the feature where you can flick a switch and automatically return to home. And the flight controller basically take control of the aircraft and bring it back from wherever it should be. Either way, what you should have when you're flying FPV is a competent pilot standing next to you so they can take control of the aircraft should you not be seeing anything more through the goggles. Anyway, my next video will be with this canopy, with DJI FPV 03 in this FMS XF robot gimbal and the VTX mount and the fan to see how well this works. Thanks for watching this one and see you again soon.